this class. So in last class we were discussing about different type of disconnection, right? So let us continue with that. Right, let us see few more disconnections. So here I have taken one example which is visible on your screen, right? So here this is one disconnection A and this is second disconnection B. I have told we always choose that disconnection which gives a good product, that is reliable, because that reagent will be available. That thing we need to check, right? We can do however we can disconnect, but we may not get the equivalent reagent, right? That reagent may not be stable. Those things happens, right? So let us see with the examples. You will get to know how we will disconnect them, right? If I disconnect like A, right? So what are the conditions? See here, this one I will get. See here, if I disconnect A, I'll get this one, right? So oxygen gets negative charge. And you may ask, why sir you only disconnect the heteroatom and the carbon atom, right? The reason for that is the heteroatom and this carbon bond formation will be very easy. For example, see here, what is this? CH3 CH2 Cl, right? Here I have NH2 group which is attached to R group. So easily I can do SN2 reaction and the bond formation will be easy. So minus HCl will be liberated and I can form this CH2 NH and R group, right? So this bond will be easily formed, this bond. So in retrosynthesis means what? We have this target molecule, but we want to determine from which reagent it is formed, right? So that is nothing but retrosynthesis. So this bond, first we break only this bond, right? Because that bond is easily formed, we know by it, by the chemical this chemical history we know, right? So because of that chemical reactions we have studied, SN1 SN2 everything, from that we can easily tell that because of that we will break only heteroatom and carbon bond. So here if I break like A, this is A, right? So if I break I will get these products, right? So if I dissociate with B, right? So this is nothing but here we use the word disconnection, right? If I disconnect in the way of B, then what happens? Let us see. So we will get this product. Here oxygen gets a negative charge and carbon gets positive charge. You may ask, why sir you only put oxygen negative charge, why not positive and to this carbon negative, right? The reason also I have told. This nitrogen, oxygen and halogens, these are electronegative atoms, electronegative atoms, right? So these can hold these have got ability to hold negative charge, right? So always whenever I disconnect, I see to it that these electronegative atom should get negative charge. So I always disconnect like that, right? So you may ask, right, here I have got A and here I have got B. Which disconnection is good? I will tell A disconnection is bad and this B disconnection is good because it is reliable. You may ask, why sir? Because see here, in case of A, you can see here, this is A I am writing. So here what I am getting, see, instead of writing O negative, can I write OH? See here I am writing, right, OH, and here pH comes, right? So this group you can see which I am routing now. So this group here, two OH group are there, two OH groups. So there may be chemoselectivity problem further, chemoselectivity. Whenever I react like these two compounds, this positive charge can react with this oxygen, right? This positive charge is there, right? It can react with this oxygen also, and it has possibility to react with this oxygen. So the chemoselectivity comes into the picture. So because of that, we may not get this equivalent product, target molecule 100% nor 90%. There may be chance of 50% or 60-40%, right? So we always see to that there should not be any chemoselectivity, first thing, and second thing, we should always get the product, right? So this B option is true. In some cases what happens, you may disconnect, but problem is this carbocation formed should be stable, otherwise we don't get any reagent in which it should give the carbocation which is unstable, right? So but here the carbocation is stable. See here, I will write it down. See, with red ink I am writing now. See here, this carbocation is stable. Why it is stable? Because of resonance like this. I can show like this, right? So here we have got resonance like this. So with this resonance, this carbocation is stable. But the problem is the chemoselectivity, which I have told you. Because of 2OH group, the chemoselectivity problem will arise, right? So I told the B disconnection is very good. So B disconnection, can I write like this? So the equivalent reagent, let me write now. So these are the equivalent reagent. So see here like this. These are called intermediates. In common chemistry we call them as intermediates, but in retrosynthesis I have told this, these all things. Synthones we call it as, right? Synthones, synthone or synthone, right? These things we call it as. So instead of writing O minus, I can write OH. That thing also I have told. These are synthones and these are equivalent reagent. So here I can write like this also. OH is there, pH. Instead of writing positive charge, I can write any good living group like bromine here. And there is one more possibility, one more reagent we will get, that is, see here. Here instead of writing bromine, what I can do, see here, just here you can observe with this. I will erase this hydrogen. So here hydrogen is there, right? So this hydrogen, here oxygen has got lone pair. This lone pair will attack to this and this oxygen gets positive charge. So this H will move as H plus. So here I can get one more reagent, that is epoxide. See here like this I will get epoxide. I hope you got it. Or otherwise you can show here also. See here I am showing epoxide using this. So here bromine is there, as it is a good living group, and here pH is there, and here oxygen with hydrogen is there. So oxygen can take this electron density and gives to this carbon, and bromine can live. So Br minus and this H plus will react to form HBr and I will get epoxide. See, this is the epoxide I will get, right? So I can use this reagent also, or I can use epoxide. Both are equivalent, right? This thing you understood, right? So what all the things I have told, the A can't be equivalent because here I am facing the problem of chemoselectivity, but B it can be. And also within B I have told this reagent only this is the possibility, but for this reagent I have two possibilities. This is first possibility and this is second possibility. Both I can use, no problem, right? So let us write the reaction now. So I have told whenever we write the retrosynthesis, then we should always write the reaction, right? So now onwards I will use blue pen for writing the reaction. So I have told the one which is lastly cleaved in retrosynthesis should be the first to react, right? So with that knowledge, so what I am adding, I am adding these two compounds I am taking. So see here, what I am doing with blue pen, it is understood that I am writing reaction. So you can observe the blue ink on your screen, right? So here one reagent and I am adding epoxide to it, right? So this is the epoxide and here pH. So here oxygen is having lone pair, so it will attack only this carbon. It can't attack this carbon. Why it can't attack this carbon? Because it is undergoing SN2 reaction. SN2 reaction always given by primary followed by secondary and tertiary. It is the order of reaction, right? So SN2 reaction, the order will be primary will give fast followed by secondary and tertiary. Here you can observe that, see, this carbon is there, right? This carbon is primary, whereas this carbon is secondary and this carbon is tertiary. So problem with that is here steric hindrance also there. So SN2 I have told only primary reaction will give faster. The reason for that is steric hindrance should be less. So primary will be no steric hindrance. Here also see, you can observe here phenyl group is there, because of which steric hindrance will be there. So to avoid the steric hindrance, it will attack this position, right? I hope you understood it, right? So what is the reaction I will get? See, just I will write the product. So in common reaction we will show it by single arrow, right? So this is the single arrow. So here I will get the reaction like this. Oxygen is there, that is reacted to this carbon, right? Next carbon, O negative came, right? And here pH group is there. O negative, since the reaction is going in presence of water medium, so water will be there. HOH I can show H2O. Instead of writing like that, I can show HOH. So this negative charge will take that and I will get the product. Here we won't tell target molecule, but we call it as product. I hope this is the target molecule which we have started with. See here, same target molecule I got here, right? I hope you understood, right? Let us see next reaction. So here, this is the reaction. See here, I can call this reaction by the name 1,2 disconnection. Why I am calling 1,2 disconnection? That thing you are going to. So what is 1,2 disconnection? See here, with red mark I am going to indicate here. This, sorry, this OH is there, right? This OH and NH group is there. So both these are functional group, let us assume, right? So here this carbon gets 1 and this carbon gets 2. 2 functional group, the carbon should get 1, like that. So disconnection possibility, see here, this disconnection will be good. Because why it is good? See here. So retrosynthesis, now I am doing retrosynthesis. Black color reaction, and this arrow, you should understand that I am talking about retrosynthesis now, right? So here what I will get, here I can write positive and here I can write negative. Instead of negative also I can put NH2 directly, right? So other things remains as it is, right? So this positive, this hydrogen will leave. Since this hydrogen left the system, oxygen gets negative charge. So this negative and positive can form bond and it can form epoxide. So it became neutral, right? Let me remove those charge and let me show neutral. So I told this reaction will be good one, right? Why? Because I got these reagent I can get. You may ask, sir, this is also heteroatom, oxygen is there and here carbon is there, right? Here also you can do disconnection, right? Let us see that. If I do disconnection, I won't get that good proper reagent further to make reaction. Because of that only we disconnect in such a way that it should give us a reliable reagent. See here, positive charge I should get and here OH negative charge, right? So this reaction we may not get like good reagent here, right? Because this positive charge can be stabilized by the lone pair, like neighboring group participation, such things may happen. So we may get different product also. So we always in such compounds want to disconnection, we always try to see that we disconnect where nitrogen is attached, because that reagents are easily available for us, right? So we try to see that it can react and form SN2 reaction, further we can do, right? So let me rub all these things, right? So it is not working, man. What the problem with that, I don't know. Sometimes it stops working, right? Yeah, let us see now. So reaction, now let me write. So I have told while writing reaction I will use blue pen. If I forget, you should not get confused, right? So here are the reagent I am adding. NH2 has got lone pair on its, right? So lone pair is present on nitrogen. So what happens? SN2 reaction. So this carbon is sterically less hindered. There is no hindrance. Because of that SN2 reaction occurs like that only. And here OH, I have told that H comes from this nitrogen also has given one H, right? There also from that it has got that. So now you are in MSc, I should not explain all the basics things, right? So these things are understood. Again no need to tell, right? So let us see what is this 1,2 disconnection. So I have explained the 1,2 disconnection, right? Let me take a few more examples and let us do that, right? So what is this 1,2 disconnection? So here I will take the example. Oxygen here nitrogen is there, here one OH group is there, and here like this compound, here one H. Sometimes I always forget this H, so it should be. So I have told 1,2, if there are two functional group like this, OH is there and NH is there, one should be given to this carbon or to this carbon. I have told that thing also. Otherwise if you do 1,2 ulta also, no problem, right? And also cleavage should be done where nitrogen is there. heteroatom and carbon atom, because bond form will be very easy, right? So I am talking about retrosynthesis. This arrow you should understand, right? So what happens, see here, other things as usual, right? O is there, CH2, CH2, OH, and here this carbon gets positive charge and nitrogen gets negative charge. I have told, instead of writing positive and negative intermediates, instead of writing these intermediates, what I can write, I can directly write the equivalent reagent, right? So what I will write, see here, this positive charge I will remove. Instead of writing all these things, I can directly write epoxide, right? So I can make this epoxide. I hope you understood. And instead of writing negative charge here, I can write one more hydrogen here, right? So this is the reagent, right? So further I can dissociate this, that is nothing but disconnection in retrosynthesis. Here I can disconnect here, because this disconnection will be good one, right? Here I can't disconnect, right? This is bad disconnection, because this disconnection, good disconnection, let me call this good as A and bad as B. Here let me write for A, and one more side let me write for B. Why B is bad, that thing also I will explain here, right? So with respect to A, what I will get the product. So if I do that disconnection, right, here I will get O negative or OH I can write, and here epoxide as usual. Here positive charge, instead of writing positive charge, good living group bromine I can put, because once the bromine left the system, this carbon gets positive charge, right? As bromine left the system, this carbon gets positive charge. So instead of writing all this positive charge, I can directly write CH2Br, this bond, right? So this is understood, right? This product I will get. So I called this as good disconnection, correct? Why I called this as bad disconnection, see here, if I do disconnection at B, which I have indicated here, so this is B, here I am doing disconnection, then what happens, see, I will get these reagent. Here I will get positive charge, and here oxygen gets negative charge, and here as usual epoxide is there, right? So these equivalent reagent we may not get, right? You may tell Grignard reagent is there, but RMJX, right, Grignard reagent. But the problem with Grignard reagent also, we need to maintain the temperature, and water should not be there, right? If water is there, then it will form RH compound, right? Those things, because of that demerit. And also in case of a disconnection, which I have written, I have rounded with red, right? So this A disconnection, we get that product which are easily available in lab. See, what is this? This thing also we know, right? Naphthols, and this also it can be available, right? So we disconnect in such a way that we should get a good reagent for the reaction, right? I hope you got it. Now let us write the reaction for that. So first reaction, the one which is lastly used, should be the taken first. So here I am going to take this phenol, naphthol, right? This is alpha and this is beta. So this is alpha naphthol. These things we know, right? To this, here bromine is there, and here epoxide is there. I have told bromine epoxide in presence of base like OH minus, that is NaOH or KOH we use, right? These are the bases we use. So this takes this proton, right? These things this proton, so oxygen gets negative charge. That negative charge will do SN2 reaction with this carbon, and bromine leaves the system, right? So let me write the reaction. So while writing reaction, I will use only this single arrow, not retrosynthesis arrow. That thing also I have told again and again, so that it will be clear for you, right? So here what I am doing, I got these products, right? O here, CH2, and here epoxide is there, right? Further, right, this much I got. Now I got this. To this I am adding this amine, right? This amine I am going to add, right? This amine, see, I hope, yeah, NH2, and this is the amine, right? Same amine I am using here, right? so that I should get a target molecule, but here we call it as product. So here also simple SN2 reaction. SN2 reaction I have done videos, right? So no need to worry about that. So here less sterically hindered carbon it will attack, and it will take the electron density, and from 1H here it will take O negative and this H, O negative and this H plus will react to form OH, and this nitrogen becomes neutral. That reaction you know, so I never write that while explaining this, right? So what happens, I will get this thing, final product here, which is our target molecule. So here OH comes, and here CH2, and here N to this, and here one hydrogen. So this is the target molecule which we were discussing, right? So I hope this 1-2 disconnection is clear. Let me take one more example, right? So that is the first example. I am explaining in depth, so it is taking much time, right? So here I'll explain with this example. This is very easy. Along with me you also keep on writing, so that it will be interesting for you also. So what is this? This is nothing but marpulin, right? Marpulin structure it is, right? So let us do disconnection. So here I will do disconnection like this: one disconnection, two disconnection. I'll do two disconnection simultaneously, because it makes me easy for further reaction. So what I will get here, I can NH I can write here, and other things as usual. Here I will write OH instead of writing that symptoms, right? So here nitrogen is there, oxygen, and here what I will get, instead of writing C here, OET here, and here one more OET, because if I do reaction, this OET will leave the system, this OET and this OET, and I will get that thing. When I write the reaction, you will get to know. Now only I will write, after this retrosynthesis only I will write, right? So no need to worry. Further what I can do, further, right? Further what we can do, here see, this is the functional group I have told, one here, two here. So 1-2 disconnection, two functional group are there, NH and OH. In such case we should disconnect NH here. I have told these things. Once you remember, then it becomes easy for you to understand, right? So what happens, H2N, NH, NH2 I can write like this, right? So here instead of writing OH, O and this epoxide I can form, and other things as usual, N, right? CH2O, other things as usual, right? I have told here only I am very interested in forming epoxide rather than writing bromine here, because bromine is a good leaving group, it can leave the system, right? Instead of writing here bromine, I will write epoxide only. That thing I have explained, right? So this is clear, I guess, right? So further what we can do, further we can split, right? Retrosynthesis, we can again disconnect here. See here nitrogen is there, and I can disconnect here. If I disconnect here, I'll get epoxide here, and here carbon gets positive charge, so I'll add bromine, because bromine once leaves the system, this carbon gets positive charge, right? And one more side I'll add, instead of negative charge I can add proton there, right? So this is nothing but marpulin. I hope you got the retrosynthetic, right? So these things I hope you got it, right? Now let us write the reaction. So reaction means I will use blue arrow, right? So last one, which I have taken epoxide with carbon containing bromine, right? So here this is the epoxide, and here I have got marpulin, NH, 6-membered ring, right? Hydroatoms are there, right? Oxygen and nitrogen. And here you can see chemoselectivity will not come, because oxygen is more electronegative compared to nitrogen, right? Nitrogen is less electronegative compared to oxygen, so it will be more reactive. So it will react only to this carbon. You may ask me, sir, why it won't react to this carbon? it is sterically less hindered and it can react here. But the problem is, see here, this carbon is there, right? The carbon which is attached to bromine, that carbon will be more polar compared to this carbon which is attached to epoxide oxygen, right? Because this bromine is a good leaving group. Once it leaves the system, it gets positive charge, so it will be more polar, so it will attack first directly here, right? So let me write. So what I will get here, epoxide will be there, and to this carbon is there, to this nitrogen is attached now. I hope you are getting it, right? Other things remained same, right? Further, what I NH2 NH2 hydrogen I am adding, right? No, epoxide, yeah, hydrogen I am going to add, because see, in second step we have used we have got hydrogen and this thing, so we have synthesized this one. Now to this I add this hydrogen, right? So I am going to add hydrogen, NH2 single bond NH2. So here lone pair, now it has no possibility, so it should attack SN2 reaction to this less hindered carbon, so it can do SN2 reaction here, right? So SN2, those things, explain those things again and again, right? NH2, and to this carbon it has attached next carbon, O comes, O minus and H, I can write OH directly. No, one more carbon I left here, one more carbon, and to that nitrogen is attached. I think you got confused, otherwise I can write, see here, like this also I can write, or this is also equivalent to like this also. See here I have made this carbon above, instead of writing I can write it below, NH2 NH2. See here, this carbon OH comes above, this attached, both are same only, right? Both are same, so I have shown you this equivalent structure, right? So this was our target molecule, right? With this only we have started. See here, this was our target molecule. No, further I have got few more reactions, right? See here, to that I need to add this, what is this, ester, right? Ester I need to add, so two OH group are there. So for this, if I add two ester group, OET is there and one more OET, right? How it will react? So here it has got lone pair, here also it can react. I can write here above OET and OET. So first it will react, comes down and it will leave the system, then it will react, it again goes down and OET leaves the system, so I'll get the product. I hope you know this mechanism. So this basics mechanism, once you know, there is no need of explaining again and again, right? You have studied all those things, right? So this carbon, nitrogen, to that morpholine is there, same morpholine, and here to this nitrogen NH2. So we started with this compound, right? So target molecule we easily synthesized. I hope you got it. So everything what I have explained is there on the screen, right? So this was our, with red ink let me show, this was our target molecule and we synthesized that target molecule. Initially we did the retrosynthesis, here further we did the reaction to get the same target molecule, which we call it as product, right? So I hope it is clear to you, right? Next, let us see few more things, right? Let us look into 1-2 disconnection. So see here, if you understand this heading, then it becomes clear for you to understand what is there, what I am going to explain, right? Carbonyl compounds. Take your own time, slowly we shall do everything, right? So see here, 1-2 disconnection with carbonyl compounds. Right, so this is, see, always how you should number, one should be given to that carbon which contain carbonyl group or any functional group I have told. But here if carbonyl group is there, one should be given to carbonyl group, 2 should be given to next carbon, adjacent carbon, where we can cleave easily. And I have told always heteroatom is there, nitrogen, you need to cleave there only, because it will give a reliable reagent, right? I have told these things. So retrosynthesis, this arrow represent retrosynthesis. So it is nothing but 1,2 disconnection, right? How 1,2 you numbered? 1 should be given to the carbonyl and 2 should be given to the next carbon, adjacent carbon, where we can cleave easily, right? That thing you remember. What I told, you should please write it down in your book, right? So here I will get this carbon positive and this nitrogen. Instead of writing negative, I can write NH here, right? And other things as usual. Here double bond, here lone pair, right? So it is aromatic. And here instead of writing H positive, right, what I can put here, one good electron living group, I can put, right? So let me write bromine here, right? So this is 1,2 disconnection. If I want to write the reaction, see, this is simple one. I will take the last product which is found from retrosynthesis, CO CH2Br. I can write like this also, just I have changed the conformation. So NH is there, from this electron density it will attack to this carbon and this bromine will leave the system, right? And this H will leave the system as HBr. Those things are understood. I should not write, but no problem. So here what I will get, CO group is there and here CH2, to that N has attached, right? So we get this product. I hope you got it, right? This is nothing but 1,2 disconnection. Let us see one more reaction of this 1,2 disconnection. Then we shall discuss 1,3 disconnection. No need to afraid whether if it records for more than half an hour, everything. Just once we understand those things, then no need to worry whether it takes more time or not, right? If you know these bases, you can go fastly, right? So here also 1,2 disconnection. DIX we can write disconnection. So 1 is given to the carbonyl. I have told carbonyl containing carbon 1, adjacent carbon should be given 2, where heteroatom is attached, right? See here oxygen is the heteroatom. So here I can cleave easily this bond, because heteroatom and carbon bond can be easily formed. So in retrosynthesis, this arrow, we always cleave heteroatom and carbon bond, right? So first carbon should be given to the carbonyl carbon, second should be given to the carbon containing adjacent heteroatom, right? So that thing I have done. Once you understand that thing, other things becomes easy, right? NO2, instead of writing O minus, I will write OH now. And here I can write like this, CHO, and here positive charge. Instead of writing positive charge, can I write Br, right? Bromine, right? Easily. And sometimes what happens, right, this, yeah, it's true, bromine, right? So if I want to do the reaction, so what happens, this can be again retrosynthetically cleaved, like this also we can show. See here, Br2. These reactions you have studied, these are the basic reactions. See here, let me write that reaction, right? So first last one which is cleaved should be taken, first one, CHO. To this bromine I am adding. Bromine means I can show, right, Br and Br. So this carbon will be acidic carbon, right? Because it is alpha. This is functional group CHO. To this carbon is alpha. These protons will be acidic, right? So this proton is acidic. So H plus it can leave. So negative charge. This carbon gets negative charge. Let me write here directly. I don't know why this. Yeah, now it's working. So negative charge. So this negative charge can attack this bromine and this bromine leaves the system. So what I will get? I'll get like this, Br here and here CHO. So I got this one, right? Further to that I'm going to add this one, NO2 and OH. In basic medium, if I do reaction, this H will go and O negative will come, that O negative will attack this, and this bromine leaves the system, right? I hope you are getting it. So here let me write CHO, no problem, and here oxygen let me write, and this is the benzene ring, and here NO2 to this oxygen para position, one methyl group is there, and it is benzene ring. I hope this was our starting material, right? And this is the starting material, right? Here this is the same starting material. I can rearrange, and if I write like this also, it is understood. Both are same only. Para position oxygen, ortho position NO2, and here right CHO, right? So this is all about 1,2 disconnection in carbonyl compounds, right? So these were the examples. In next class, let us see 1,3 disconnection and other things let us study. Till then, take care.